When we talk about site deployments or implementation, we have like this, all of this kind of work to install a site. I mean, we have like this picture that I take in one place here in Mexico called Tepoztlan, out the south of Mexico. And I think I really like the place because it was like a very far away, and you can see over there like a tower. I mean, I like to take pictures about everything and also about towers because that's our area. I mean, the wireless and the telecommunication. And so every time I see one of these tower, I always think is how they put all the equipment there, from where the equipment coming from. If they were from China, from Germany, from Japan, from any place, and how they built all of this site. So today, this is the content that we are going to talk about today for this exploring the RAN sharing introduction, like the main concept, like what is needed to build in a site, the general concept of infrastructure sharing, the RAN sharing options, the benefit of RAN sharing, challenges and considerations, some case studies, and final consideration and the part of question and answers. I think every one of us has like a different experience with the telecommunication. I mean, we started like several years ago making a call from a fixed phone or sending a telegraph. Then we have like this, we start using this SMS with all our phones. And what we have now is we can communicate from anywhere with video, SMS, voice, send pictures, send videos, and all of that. And so we maintain that communication. But the thing is how you make that communication possible. I mean, what is necessary to build this communication system to allow all that communication, as mentioned. So first, I would like to talk about a little bit about the main concept we have. For example, one of the main concepts we need to know is mobile infrastructures. We are talking about hardware and software that support the mobile offering or the mobile installation. Also include all the management and administration for all mobile devices in the organization, the software, security, and other tools, as well as logical requirements. When we talk about infrastructure, there are two main groups that we talk. We talk about active infrastructure. We are talking here about all the RAN equipment, as we can see here, like the BTS from 4G, 5G, or whatever generation, the core that could be like just a standard core or a cloud core or an open RAN core, open source core, whatever version of core we have, and also all of this transmission solution. But when we talk about passive infrastructure, we're talking about all of those elements who support those active components. We are talking about physical sites, we are talking about buildings, shelter, towers, power supply, and battery backup. In terms of communication, I mean, we have like this very good concept that from Mr. Matias that is always explaining this in like in every presentation, like the 5 main components in a mobile network. We have the core part, we have the core part that depending on the generation, we call it like in different way. For example, in 5G, we just call it 5G core. We have the radio part. Also, in different generation, we have like different components like BSC in 2G, RNC in 3G, E0B in 4G, and right now we call it like the general name is G0B for 5G. We need devices, different kind of devices in the network. We have fibers with the different solution to provide, we have transport with different solution to support the transport like fibers, satellite, microwave. We also have one special that is called integrated access and backhaul that is essentially using the same BTS for 4G or for 5G to make the backhaul or the transport. I mean, to have like we have, for example, here that we have the BTS providing coverage here, but also we use the same BTS to make the transmission to this to communicate with the core. So that possibility or that feature is also possible with this called IAB. The next part is for sure the spectrum, that we can have licensed spectrum, non-licensed spectrum, low, medium, or high. We also have we also have something called sub 1G, that is like the commercial or the typical commercial spectrum. The sub 6G, that in most of our countries are unlicensed spectrum, millimetric wave for high bands in 5G, and what we have the definition in the license band, the RF1 low bands and the RF low and medium bands, and the FR2 that is correspond to the millimetric waves. When you build a site, no matter if it's rural or urban, it's not an easy job. Maybe you are passing, to have like this installation here, you pass or you move equipment from some other place, you transport equipment from boat, train, car, by sea, by air, but all the means to put a site in operation. In urban site, also that, but you also have like other issues. For example, like how you put all of this tower here, where are you going to get the energy for this place? Where are you going to put the grounding on this place? If you need like this kind of lighting protection solution here to protect against lighting, if you need like protection around the place. So it's not really an easy job. Involves a lot of working. We need a lot of like project management, like mentioned by Mr. Noel, like in the last presentation, that we need to coordinate like certain things to make this location or this place available to give coverage in one area. And also you have like this poor guy here mounting on the tower to make all the installation. So it's not easy. You have to transport equipment, you have to install equipment, you have to put everything on the tower. So you need a lot of work, a lot of time, and a lot of effort to make this kind of work. In this slide, I wanted to summarize a little bit like what are the elements to make to building a site. Like it could be a rural area or in an urban area. They're going to say it's going to be more or less the same. So the effort, the time, and the cost for deploy a site are considerable. You need to define location, you need to check regulation, and you get permission to install there. It's not just go there and put the equipment. You need a lot of time and a lot of effort to get permission to install in one site. According to the DGTI Infra, the total cost to build a cell tower in the United States is around $250,000. In Western Europe is around $135,000. In Latam is around $110,000. Maybe the price in your country will be somewhere around there. This cost can change based on site location, terrain, and the type of the tower. Anyway, just to give you like the reference, let's gonna say, for example, in the America Latina, for the price of $100,000, around 20 or 30% of that price is just equipment. Around 70% or 80% are all the equipment, the auxiliary material around to install the site. As you can see here, you need the mobile, core. You need a transmission solution, whatever it is, satellite, microwave, fiber optics. You need to install the tower. You need to put the RF module and the BBO module to install here. It could be like traditional BTS or Open RAN BTS, whatever that is available there. You need to provide coverage. You require a lot of service people working over there to install the equipment, to make the simulation, to make configuration, testing, optimization, and all of that. You need equipment and battery cabinet, civil works, make the grounding, energy, additional energy solution or whatever, protection, and also you need the transportation, to bring the equipment from whatever part of the country is made to your local site. So really, it's a very hard work. So every operator thinks a lot before building a site. They make a lot of estimation calculation to decide whether or not to install a site. some is very, very expensive. Let's gonna talk about $200,000 until and $100,000. So it's a lot of money, a lot of effort, and a lot of time to do that. So they have to be very careful. I mean, every operator to install site over there. So they try to make cheaper and make easier those installation, and for that they start thinking about how to share all the costs for this site. Also, there is like another problem or another issue that we need to consider when building a site is about the coverage. Even though, as you know, the 5G network are more spectrum efficient than 4G networks, some mention about 3 times more efficient in terms of spectrum, but they require more sites because you are using higher frequency and you have shorter range and lower penetration. So instead of having, for example, one site to cover an area, maybe you will need maybe 2 sites, 3 sites, or 5 sites. So, for example, here in this slide, these are just referential image about how is the coverage. I mean, for 5G, like in different frequencies. These are just referential numbers. I mean, they are not final because you need to establish like real coverage. You need to make the coverage analysis. But just to to have like some idea about all of that. For example, when you have like this low frequency in 5G, like below 1 gigahertz, you have like a big coverage. The coverage is equivalent to what you have in LTE. Maybe you can have here like 6 kilometers, 10 kilometers of coverage. When you are working with medium frequencies, let's gonna say between 2 and 6 gigahertz, the coverage is much less, but you have more capacity in terms of throughput. I mean, here we can talk about I don't know, 100 Mbps, but the coverage will be like 3 kilometers, 4 kilometers for this place. But for the millimeter wave, you have like very high throughput, but the coverage is very small. I mean, you can have, as you can see here in this image, some number like 300 meters or 500 meters. So beside the problem or the issue that we have before about how to build the site, we also need to consider the frequency, the spectrum that you are going to use. I mean, to provide like a very good coverage and a proper throughput for that place. So anyway, as I mentioned at the beginning, if you have any question or comment, you can just put it in the chat box and we will try to answer all of them at the end. So for all of the issues that we see before is why we need this infrastructure sharing. In the telecommunication refers to the arrangement that one telecommunication facilitates to share part or all of the networks to other operator to provide service. The sharing can include both active and passive element in the network. As we mentioned before, we can share just the installation or we can share active components over there. The regulatory framework of a country should facilitate all type of infrastructural sharing. I mean, every one of our countries, they have some regulations that allows or not allow how to share those components between different operators. In some countries, it's much easier. In some other countries are much difficult. For example, here in Mexico, usually you can share equipment, whatever you want. There is no big issue, but you just have to make the permission or to ask the permission for the other operator who has the property for that equipment. I think you have seen this slide like in some other presentation, but it's just to show about different way to share the infrastructure. As we mentioned, we can share passive components like energy, like space, like the site, like transmission, and also you can share active component in the network like the core part, the radio controller, the base station, and also the spectrum. So depending on what you are sharing, you will have more or less work. So we are going to focus in particular on this part here, on the active sharing. I mean, whatever is focused on the RAN sharing and a little bit on the core network sharing. So we are going to start with this run and code sharing option in the active part. In the active part, as you see, we can share also the core network. This radio controller, usually we don't see so much because this is more focused on the 2G and the 4G, the BSC and the RNC. The backhaul, the base station, the site, and the spectrum. The thing is, we have like this main typical. The Moran is where usually you are sharing almost all of these components here, but the spectrum is divided. One operator has part of the spectrum, the other operator has this other part of the spectrum. In the mock, anyway, we are going to explain that in the next slide. The spectrum is shared. I mean, no matter how many like operators you have here, you are sharing the spectrum. There is no differentiation between what part of the spectrum is for one operator or the other. I mean, you just share the complete spectrum available for the operator to whatever operator you need in the network. And the other one is the core network sharing. I mean, you are sharing like all the components, including the core. So based on this, you also have, or you can also share using those, let's gonna say, specific model that, for example, is the NBO and the network slicing model that we will explain in the next slides. When we mention about mock, is one of the run sharing option that we have. The mock refers to the multi-operator core network in the telecommunication world. It's allow multiple network operator sharing the same radio while maintaining separate core networks. As you can see here in this drawing, I mean, we have this core network from operator A, this core network in operator B, and you share the complete spectrum here. For example, this frequency 18,000 megahertz for the two operators. This is one of the most typical configuration that we have in all of this sharing. I mean, let's say it's one of the easiest because you are sharing the frequency. You don't do like so much planning. I mean, you do like the regular planning for this, but you don't care so much about who is using one operator or the other operator. I mean, you just have like this main differentiator, that is the PLMN, that is the ID for the network, and you use the complete share the complete spectrum. For the base station, there are some configuration issues over there, but essentially are features that you get from the providers, either from traditional RAN providers or the Open RAN, because anyway, it's a feature that is available. I mean, from any of those traditional or Open RAN, that is a basic feature that you have available. So it's activate the feature, and you define those components in the profile of each one of the operators. As mentioned here, enables resource efficiency and cost saving for the operator, because you don't need to install one site for one operator and one site for the other operator. As we already mentioned before, I mean, you don't need to double or triple the work because the work was already done by one operator, and you can use that. You agree with that operator, and you can start sharing using this mock model here. The main challenge here is the technical complexity, because anyway, you need to make some configuration. You need to do some technical configuration in the network. There are some security and interference concern. There are some additional expenditure because maybe you are going to use more power here in the network, because you are going to transmit to allow coverage for these those users here. And in some saturated markets, it's a little bit complicated because, you know, it's so tight competition between one or the other. But anyway, we have found that like this operation model is good. I mean, in particular for those rural areas or difficult to access area, is very good because you simplified a lot the cost. I mean, you don't have to pay like those 100,000 dollars for installation aside, because you can share part of those costs. And the next model we have is what we call the MORAN, is multi-operator radio access network. In this one, you are sharing everything, antenna, tower, side power, except this part we have here. We have one part of the spectrum to be used for this operator, and the other part of the spectrum used on this part of the operator. Anyway, with this, you share the G node B, or you share the node B for 4G or for 5G, no matter for this model. Also, this feature is also available, I think, from 2G and 3G is also available in the network, but it's more useful, I mean, for 4G and 5G, because it's a little bit more complicated, I mean, to install a site. So as you see here, we can have like independent core here. You share the node, but the main differentiator for the MORAN model is you have part of the spectrum for one operator and the other part of the spectrum for the next operator. So they have like this independent cell coverage. As mentioned here, each carrier is independently configured and managed. So you have like different cell resource, different core network, and this solution is for scenarios where operators need to maintain service and deployment independent in a shared environment. So you have here independence is a model of active network sharing. You need a good control at the cell level. It's just not one unique, as you did, for example, in the mock that we have in the previous slide. You share hardware, but anyway, you have to control the cell levels in each one of these on this cell, because you will have one cell here for this operator and this other cell for this operator working on the network. A spectrum independence, you have to maintain independent frequency spectrum. So you need to coordinate and optimize the spectrum usage. You have to be sure, or you have to double check, I mean, what part you will do for, you will assign to one operator and what part of the spectrum you will use for the other operator. So those two are like the main RAN sharing options. But anyway, there is like another model based on sharing of the core. That model is called, for example, this MVNO. That this MVNO refers to a virtual operator. Let's want to say, is a model, as we can see here in the network, where you have like this traditional operator here, that they already have like all the hardware, like the towers, the core network, all of the installation. For sure they have the spectrum also. I mean, also they are owner of the spectrum. They own the database for the subscriber, the ASS or whatever name they have in the 5G networks. But you need to share the network to other operators, because the regulator in that country allow this mobile virtual network operator model. So for this mobile network operator, there are like different subtypes. I mean, you can create operators using this infrastructure from this mobile network operator. You can have like this small virtual operator, like 1, 2, and 3, yellow, orange, or red, using this component called enabler, that is like a technology, a software, essentially software that allows you the interconnection to this mobile operator. And so with this enabler, you can create these small operators. So for this MVNO model, you can have like different types, depending on how much hardware or software you are going to use from the base operator, from the mobile network operator. For example, the most basic one is this one that is called reseller or thin MVNO. This one, as you can, sorry, as you can see here, they are using like the complete, almost like the complete network or hardware and software from the mobile network operator, from the radio access, the core, the application, and all of the supporting, the billing and supporting solution. And you just resell that traffic to your customer. You create like a new operator like Yellow Mobile using all of this, but from your side, you just use the marketing and the sales. I mean, you ask this mobile network operator to provide some packages, and so you will resell that service. The other part is the service provider, where you can create, as you see here, you use your billing solution, but you use the rest of the core or the rest of the platform from the mobile operator. I mean, you define your package for here. You define, for example, like one Gbps of throughput. I want 100 gigs of capacity per month. I have this throughput and I need this kind of services. So for this, you have this service provider because you define the service you want to provide to the customer. The other one is the enhanced service provider, because in this way you have like more flexibility to define your packages. It's not just putting like a price or a special billing, but you can also group the packages. For example, you can put here packages for voice, for data, for SMS, for Wi-Fi, for whatever service you have available over there. And so for that reason, they call it enhanced service provider. And also there is like another, like a full model that is called full infrastructure MVNO, or you call it thick MVNO, where you just use the radio access part from the mobile network operator, but a big part of the core network application and billing also belongs to the mobile virtual network operator. But as you can see here for this image, you need to have more hardware, more software, and more, let's gonna say, money to build this configuration. For this, maybe just not so much hardware and software. For this service provider model, maybe just some solution made on the cloud, and on the reseller, the investment is very thin to make this kind of deployment. So this is a particularly very interesting model that is used like in several of our countries, where you are using the traditional mobile operator to create these additional mobile virtual network operators, and you put it like just your brand. So far we have like three models. We have like the MORAN, we have the MOC, and we have the mobile virtual network operator model. So another option here also to share the network is to call network slicing. In this network slicing, we define like several logical networks in an infrastructure. Each logical network, as mentioned here, is defined to serve a particular business purpose and comprise different requirements: core, transmission, and RAN components to provide the service. In 4G, we have something, let's gonna say, equivalent to that network slicing that was called QCI, or quality control indicators. I mean, you have like this 12 QCI, then in release 12, they define it 4 more. So in total, you have 13, I think. In total, 13 QCI here that are configured in different components in the network, from the core, from the transmission, and from the radio access. So you can ensure that the traffic has like this quality indicator configured in the network. So for example, if you want to define like a tunnel just for voice, you define, for example, QC1, and for that to ensure that you will have like this packet delay, that you will have this packet loss, and you will provide like this kind of service. But for example, if you need some data transport, for example, maybe you will, sorry, maybe you will use like this QCI here, for example, QCI 5, to transport that traffic. So you can define like different traffic for this kind of services. So as you see here, we're talking about 13 QCI here in the network to define like those 13 possibilities here in the network to define a bearer for a specific traffic. So in every one of our networks, even traditional RAN or open RAN, you have like this basic parameter in 4G. When we have like 5G, we are talking about slicing. That is like a much better evolution of this QCI that we have in 4G. We are defining a slicing to define like different opportunities of different kind of traffic here. For example, you can have these 3 slices, for example, for this kind of service, for these V2X services. For automatic driving from Fiat, you define another slice. And for public safety, you have like another slice. So this is a typical feature that we are having in 5G, in particular when we have like 5G standalone solution. So for this, you have a parameter called NSSI to define like what slice you are going to have in this. So you have like this parameter that I call NSSI AI to define this slice in the network. So here in the QCI, maybe you have like 13 possibilities to define tunnels in your network. Here, based on the definition of the NSSI, you can have around 1 million possibilities or possible slice to define from the core network in the transport slice part and also in the RAN. So imagine from 13 to 1 million or more in this network. Anyway, each provider will tell you about the exactly number, but at least by the definition of the parameter for network slicing, we're talking about 1 million. But maybe the provider, for whatever reason, they will say, oh, you will not have 1 million, because anyway, you will not use 1 million, but you can use like 100 or 200 slices. But anyway, 100 or 200 slices are a big number. So, but anyway, just have like this number just at the back of your mind. I mean, in your mind, like 1 million network slice available here on this to differentiate your traffic. So here you can have fixed, for example, fixed, because for example here, just to give you like an example. For example here, if you want to have fixed wireless access, you can just define one QCI. Let's gonna say QCI 5. But if you want to put like another operator to have fixed wireless access, but with other priority, with another packet delay, you cannot define it, because you just use that QCI for one operator. But here with 1 million, with 1 million possibilities, you can define as many slices as you want, with as many traffic or particularities you want, like with delay, throughput, data consumption, whatever, depending on the customer or the user you are going to have here at the end of this site, of this part of the radio part. So the other thing is about this neutral host. Anyway, it's not like a particular like hardware or software sharing option, but is a concept. In this neutral host is like a concept. I mean, whatever you can use over here, you can use here the MOC model, the MORAN model, the MVNO model, whatever model. But essentially what it means is somebody's responsible to make the installation in this site. For example, you have like this building or this shopping mall here, and or maybe like a football football area or a soccer area or whatever, and somebody is responsible to make all the hardware, all the infrastructure deployment here in this site, to put like let's gonna say the tower, the DAS solution, the lamp site solution, or whatever solution you want there, and he rent that service, or they offer that service to a third party. So to operator A, operator B, or operator C, to provide coverage in that model. So this neutral host is like also a possibility that we have of market of the technical deployment here on this side to simplify the deployment that could be used in urban area, for example, to this big building, big commercial building. So the operator, they don't have to install equipment by themselves, but a third party is interested on doing business here. So they build the site, they put all the equipment, and they just rented the site to mobile operators, A, B, or C. Also, this model of neutral host, as mentioned here, could be also used in rural site, because also, as we see in the previous slide, in rural site, it's also very complicated to install a site. So this neutral host is also an operation model that is used for those sites because helps to deploy universal. There is one concept. There is a concept also that we use a lot of here in Latin America, that is universal funds, or funds to be used in public services, that could be also do work in this neutral host model. Because, for example, if you have these universal funds, or whatever name you have in your country, in every one of our countries, you have that funds to build sites. And so you build, for example, this site in a rural area, and then you call the operators to operate in that using that network. So the operator, they don't need to invest money to deploy a site. This rural site, using universal funds, they pay for all of that installation, and like similar like you have here in this slide, they built, with universal funds, or funds from the government, or funds from the telecommunication regulator. You install the site in a rural site, for example, and then you rent that traffic, or you rent that platform to mobile operators to be used over there. So so we have seen like these different models for RAN and core sharing, but what we can say that are the main benefits of this RAN sharing? First, I think one of the most important is the cost saving, because you can save all the cost for installation, reducing the capital and operation expenditure, as well as optimize all of this environmental issue here, because you don't need to install like 2 sites or 3 sites in a place, using energy, maybe putting some contamination, let's gonna say contamination in the air. So it's a little bit compliant. It's a little bit compliant with the environment. The other one is operational efficiency. You are using just one equipment to deploy, so you are not over provisioning. You are optimized as much as you can. All the hardware to be used by 1, 2, or whatever operators you can work over there using these RAN sharing models. The other one is environmental impact, as mentioned. The energy consumption is much less. Also, the carbon footprint of the network is very low, so you can contribute to the environmental sustainability. The other one is about the service quality, because you can optimize all the resources over there. You don't need like so many people working on one site. With a few people, you can maintain the site, and you can provide services from different operators, or one operator on one site. The other one is flexibility and innovation. It is also related to this part of cost saving, because you have more flexibility to innovate because you have only one site. I mean, to invest, to give all your time, all your effort, and all your money to improve that equipment over there. I think this is a very good document. You can Google in, you can search it in Google. That is called ITU. In particular, this number here, D264, is a recommendation from the ITU that provide information about all of this cost saving, tariff reduction, and enhanced competition using infrastructure sharing. This document is not that long. I think there are like 10 pages, and where they provide like some good arguments about why you should share your infrastructure. For example, they say here that if you share the infrastructure, just the passive part, you're going to save around 30%. You're expected to save around 30% of the cost. But if you can share like all the infrastructure, all the active infrastructure, I mean, radio access, transmission, site, and all of that, you can have saving of around 50 or 60% of saving in the operation, in the installation and in the operation of that site. Also, that same document, you can search it. D264 D264. They also have like this very nice drawing about how much network you can consolidate from fully separate networks to consolidate operation, having like going from passive to active. And here you see like how much you can save. They say here that when you can share like almost everything, you can have saving of around 40%. I'm going to put it here. And also you have like 3 operators, you can save around 50%. So the numbers are very big of the reduction, of the optimization, of the cost reduction of using all of these sharing options. Anyways, it's a good option for rural areas, also for urban areas, because I mean you are not going to install like 3 towers on the top of a building. I mean, if you can install only 1 tower, that will be much easier and cheaper for everyone. Challenges and consideration. There are like some particular issues that we have when we use this sharing option. One is the interoperability and end-to-end performance, because like this multi-vendor run environment, like with traditional or open run environment, you are putting 2, 3, or whatever quantity of networks operator on the same hardware. So you have to be aware, or you have to double check that you can put all your features, all your pricing, all your pricing structure, and all your traffic structure over there, and using this run environment. I mean, it's not just put the BTS to work, but you have to check all of this configuration about if that hardware that is being installed or was installed over there is it has the features to support this RAN sharing. The other one is the network management and resource management, because every operator, they have their own KPIs, they handle spares, they have training resources, they have like different elements in the networks that are like work like in different ways in different operators. So in this, you have to agree of how and who will be responsible for all of this management. If it will be together from different operator, or just one of them will be responsible, and the other ones you will just watch. The other part is about technical complexity and security risk, because you have like 2, 3, or whatever operators working on the same infrastructure, and so you have to check about whatever security risk you have over there, to ensure that it's compatible with your network yes, with your network policies about securities, and if you need to adapt to the operation of the other operator who are sharing the same hardware. And the other one are the regulatory barriers. I think this is one of the most important issue here. Is you need this to comply with the regulation in each one of the country. And if you don't have like this regulation to share the network active or and passive components, you need to check this with the regulator and with the operator. I mean, to make this RAN sharing option available, if it's possible, in each one of your countries. So now we're going to talk a bit about the different case studies. I took like this some referential cases from different countries. I think you know some of them, at least. I think you know some of them. For sure, you know this one. This one, Gomo, is from your country, from Philippines. That is a fully digital telco provider. That is like the official name, fully digital telco provider. But if you see like in the small letters in the contract, in the operation, it's an MVNO. Why is an MVNO? Because it's using the main operation, the mobile network operator of Globe, and based on this mobile network operator, they use this model of MVNOs to provide service and to make marketing of a new service called Gomo or Gomo SIM service. I think you know more of this part. Maybe you can explain me more of this one. But as you know, it does not own any radio frequency band, so it's using the MVNO model. And in my understanding, they are using this MOC model for the operation. So as you can see here, I think it's a good example of all of this example. For one side, what is the MVNO, where you have the mobile network operator Globe, and you have this MVNO called Gomo. Also, you have this MOC model because you are sharing the same spectrum for the operation of Gomo. So you don't have like two pieces like you have like in the Moran. You just have one spectrum for the whole operation. That's why it's MOC. This Gomo, you can see here, it is in operation in Singapore, Ireland, Thailand, and in our beautiful Philippines country. They start operation in 2020, and here is just like the map about the coverage. So you can have a look about what they are doing in your country. This is from the country I'm living. Is called Altan Redes. As we have here in the network, this Altan Redes is a wholesale for MVNO. Why is not like an MVNO? Because this one is just for wholesale. Here in Mexico we have the like four main operators. We have AT&T, we have Telcel, we have Movistar, and we have this Altan Redes. The three main operators, Telcel, AT&T, and Movistar, they are traditional mobile operators. They work also on this MVNO model. But Altan Redes, the particular thing, and I think it's very interesting to check, is they are just for wholesale. I mean, they don't sell directly to end customer. They resell or they wholesale the service to different clients, and so they sell everything. If you check the page, you will not see they're selling for user or for a person. They sell it to companies, to whatever company they want to sell services. Like for example, all of this one here, they put their brand over there and they sell the service. In some of the services, you can see in the, let me check here. Let me see if I can show you here a little bit. No, I cannot make, anyway, in the network, you can sell, you can have your network, put it here in the phone, the name of your network, or from the, let's gonna say from Altan, or you can put like this Oxy or Dish or whatever MVNO you have over there. So there are like different possibilities here in this MVNO model they have here. They are talking about 114 customers here using this kind of services. So this mobile network operator is using LTE over the 700 megahertz spectrum, and in Mexico is expecting to have like 92% of the coverage for by 2024. So they have, as mentioned, like these 114 wholesale clients or MVNOs and MVNEs right now, and just to have like a number like around 6 million users. Maybe the government in your country has like much more, but I think this was interesting because this was like a wholesale for MVNOs. So you have this mobile network operator, this MVNO here working, a customer here. This other model, I think is also very interesting from our friends from USA. It's called the FirstNet. You know, in the United States, because all of these security issues, they decide to have like this mobile operator for public safety. They say, man, we have like a big country here. What we can do to make sure that all of them, they have like a very good solution for security. I mean, you have firefighters, you have police, you have whatever security over there, you have ambulance and all of that. But what happens in all of our countries is like each of one companies, or let's want to say each one of those organizations, like police, fire alarms, clinic or hospital or whatever of that, each one of them, they use their own solution. For example, they can have like Tetra, PIP 25 and all of that solution. But these people here say, sorry, security is a key issue for us. So we need to cover all of this city with a good solution. So what we decide here is to have like a solution. They use this band 14, I think is somewhere explained here. They use this particular spectrum for the whole country to provide this kind of services. So let's want to say is something called it could be called like a neutral host model, like having here like their network working for this kind of network, but also because they have like this kind of agreement with the AT&T, they share part of the network for, let's want to say, for part of the commercial AT&T operation, and part of the operation of that network of those sites for this FirstNet. So in particular, they are using this band 14. I think it should be 700 frequency, 700, yes. And here we have like a little bit of the history. I mean, they are like different. The critical communication, like all of this critical communication, you typically use RAN sharing today. There are countries, for example, in Mexico, that they are not using that. I mean, we have like every part of the country, every organization, they have their own system. But there are some countries, like for example, US with the FirstNet, Finland with this operator, France with this operator. All of them, they use this RAN sharing, in particular the MOC, for critical public safety communication. FirstNet is a nationwide wireless broadband network in the US dedicated to first responder. After this terrible issue, the 9/11, I'm just going to pass that, that's terrible. So this one is like a public-private partnership between the federal government and the AT&T. They have like this agreement to build all of this. And if you check the webpage, I think it's very interesting also to check, and maybe, I don't know, maybe in some time could be also deployed in your country and my country here, is to have like this public network. I mean, they have like this network deployed to and all of this. And for example, if I am the chief of the fire fire area here in, let's gonna say, the fire group here in the Boston area. I contact this guy in the FirstNet and say, I am from the public area, from the public service, and I need to have access to use your network to cover my area here. So it's something like a very interesting model that we have, that we can check. That I think it's a very good example of how they use this, let's gonna say, a neutral host mock model to share like a network to be used for security issues. This one was also very interesting. This was by Mr. Richard. He shared like this case, and I checked it, and it's very good. So thanks a lot to Mr. Richard for this one. So here is, we're talking about Mayutel. Mayutel Peru is, is like a South American country. They start operation in 2019. They deploy 3G and 4G. And one of the things that is more interesting about is they focus on rural areas. This one was, let's gonna say, a work between this operator here called Mayutel, our good friend from Telefonica, and the good friend from Parallel Wireless. So they make like this, I think for sure you know this name, Open RAN solution, with network sharing using the MOC model. Because considering this site that are very far away, wow, like moving all of this equipment here, they got in touch with this Parallel Wireless, or also they talk with this Telefonica, to improve this rural connectivity. So maybe here, no, it's not Mr. Richard around here. No, it's not here. So they make this agreement to improve the rural connectivity, because we have like this issue in all of our countries. There are places that are not connected. So this one, the concept here of Internet for All, that is one project also interesting to see, Telefonica Internet for All project. They focus on deploy this mobile infrastructure to install all of this site in these different places to provide coverage over there. So they create this, let's want to say, this figure called Mayutel for rural coverage using Telefonica and also Parallel Wireless using Open RAN solution to provide coverage about more than 1,000 new communities in rural areas, and provide services for more than 300,000 people over here. So here I put some names, but anyway, if you don't remember this name, you can ask Mr. Richard, because he knows a lot about all of these projects, or also me, don't worry. So checking, because we see like several of them working only with the mock model and all of that, but I found like this today, I mean just today before starting all of this, is about this case study in Europe. If you want, you can check like this network sharing 5G area. I mean, if you want to take a picture of this and check this scenario, because they show like this very good graph about what is going on in Europe and all the models they are using around there. For example, here you see that a lot of them, they are using MOC to provide coverage. This is Finland for sure. Some other operators are using MORAN. For example, England, MORAN operation, MORAN in Spain, MORAN in Italy, here, MORAN. So as you can see here in this one, you have like different good example of providers or operators like in Europe. I mean, it's not just like our specific country like Philippines, Mexico, or United States. I mean, there are several countries around there working with these different models of traffic sharing, even using MOC, MORAN, neutral host, MVNO models. So there are several models to share active or passive components, and it's really good. I mean, to know what is going over there about all of this technology. So I think for the final consideration, well, we can say about this. I mean, we always have to remember that we have sites like this, for example, in Mexico, like or in Philippines, that is a little bit difficult to deploy. It could be urban site or a rural site to deploy. So we have, it's a good opportunity for operators to optimize resources, reduce costs, and accelerate the network expansion, particularly in difficult to access areas that we have, for example, here. For sure, all the operators, or we, I mean, we and you, like professional in this telecom area, should check the regulatory terms in each one of our countries, the technical and operational implication for the run sharing. It's not just say I'm gonna run sharing. It's just to check, and in this one of things, it works a lot about, let's gonna say, like in good ways, not in bad ways. In good ways, if to have friends all around in the market. I mean, to know people, to improve a lot our network, about networking, to know people who knows the network. For example, to know our friend Mr. Richard, to know Miss Bibi, and all of those people who knows a lot about the network, the regulatory, and all of that, to help us to define this and to propose this kind of model in whatever operator where we are working. The other one is understanding the benefits and challenges associated with the different run and sharing option to take the better decision and align with the strategic objectives. Because maybe the focus from one operator is just improve coverage, but to improve that coverage, they could use this model to do it with a very optimized price. The successful implementation of run sharing requires robust collaboration and clear agreements among the both parties, because you know that you have to negotiate with the people who is going to where you are going to start the place. You have to double check with the regulator in each one of our countries to know if that model is available and under which condition is available. As the telecommunication industry continues to evolve, run sharing is playing a very good role in shaping the future of wireless, in the future of our wireless network. I mean, although the operators right now, we are talking, there are like 2 or 3 main topics that we have right now. One is trying to migrate all the traffic from 2G to 3G to 4G and 5G. And the other one is how we can do it in the best optimal way. Like what is the best way to make all of this evolution? I mean, using Open RAN, using share rate, run sharing, and all of these models. So there are like different options that could help us, I mean, to make this evolution as fast and as smooth as possible. So I think this was like my final slide. I just put like this one for general information. Is about the challenges we have for this 5G and 6G. This is, I think this is a very nice report about how has been the evolution from our 5G, going from our friends Huawei in 2017 with one of the first research for this technology, with all the different groups that are working right now to make the evolution, including satellite evolution, different operators. Also, the Open RAN should be somewhere around there. And when we are expecting to have all of this. So this graphic and this document about this evolution is very good.